Hey guys, welcome to my YouTube channel. It's been a while. I did not make any video. I was busy at work and other stuff. But lately, I've been getting a lot of questions about BGP, OSPF, and the basic or kind of a little bit more advanced configuration on BGP, load balancing, route maps, IP prefix list, and all. So I thought it's a good idea to go and make a video so that by doing so, by making a video, I also recollect my skill, my knowledge, right? I mean, as you all know, in networking, especially for me, if I don't do stuff for a long time, I don't remember it. That sounds weird, but that's how it is. So in this way, I would recall my memory, my skills, routing and switching skills, and at the same time, if I make a video which could help people like you who are learning routing and switching, or have some questions or not clear about it, or you also like same boat like me, like want to refresh your routing and switching skills. So I thought of making a quick video and go over it, so it kind of help you and me at the same time. All right, so what you see on my screen here, for example, I'm using JNS3. On the left side of the screen, just assume that so let me begin with saying, in this video I'm going to show you the basic BGP configuration, OSPF configuration also, and load balancing method, right? How we can manipulate or influence the BGP path selection. So let me go ahead and quickly share the diagram and topology so we are all on the same page. On my left, you see here I have an office here in the New York office, right? On to my right, sorry, this is my left, and on to my right here in the Dallas is branch number 2, or let's say it's the main office. So basically, I have two locations, New York and Dallas, and these two locations are connected by our two ISPs, ISP1 and ISP2. Right. For especially, this is my edge router here. This is my edge router, and this is my switch. It looks like a router on GNS3, but this is my core switch sitting behind this edge router. So my router in the Dallas location, if I have to stitch like this, right, this is connecting to ISP1 and ISP2, and my router at New York office is also connecting to ISP1 and ISP2. I mean, this is just a cloud network. There could be hundreds and thousands of other routers. The ISP might have between this Dallas and New York, which is like 1,200 miles away from each other. So we are connected with our ISP1 and ISP2. So our Dallas office has an internal network behind this core switch. For example, like loopback network 111.1 and loopback 100.1.1. I mean, this is just an example. Usually they might have hundreds of networks and VLANs and so many things, right? For the sake of this video, I'll just say like two networks. So we'd be advertising this to you. Let's see if I can do this guy. Come on. So basically, let's say like I have to advertise this 1.1.1 network and 100.1.1 network to my New York location. The people sitting behind in this office wanted to access to this, right? So how would we do that? I will advertise to our router 4, the edge router, through BGP. That it could be iBGP, internal BGP, or it could be any IGP protocol, or say like for namesake OSPF. So we're going to configure OSPF in the beginning here so that I advertise my loopback interface to this, the network's loopback 110.0.100 to the router 4. Then router 4 would have a BGP between this two ISP1 and ISP2, and ISP1 and ISP2 would advertise the same routes to the New York office. Now that we advertise this to, say the management decides that ISP1 should be the primary. Anything from this office should be coming from ISP1, and ISP2 would only be listening mode, the standby mode. In case of anything goes wrong there, then all the traffic between New York and Dallas should take this route. from New York to ISP2, then to Dallas. But when everything is working fine, we want Dallas traffic to go to the router 4, then router 2, and the New York. So by default, I don't know how the BGP will do that once I configure. If BGP is preferring the router 2 to connect between the Dallas and New York, what I'm going to do, I'm going to influence that path and make ISP2 primary. So based on the scenario, whatever the BGP choose the best, we will go and make the changes to manipulate the path, right? So let's go and first configure our OSPF and advertise these routes from the internal routes to our router 4. Then we'll see if we can ping each other. Then we will configure the BGP. So yep, this is going to be a 30 minutes video. So sit back and relax, and let's get started. I want to apologize to you all. I'm not using a secure terminal or other things. I do have one, but for some reason it's not working on this Windows something, so I have to open multiple windows, so just keep that in mind. So let's get started with our OSPF configuration between our external switch 1 and router 4. Right, so let's get started. All right, there you go. First thing first, what I do, let's put this guy here. So IP interface brief. Let's see what IP addresses we have. What's going on here? I'll try to be. All right, there you go. So I have a 3 network, 3 IP configured on this external switch, 50.1.1, which is connecting to the router 4, and my internal networks 1.1.1, 100.1.1, so forth, so on. So let's go and configure our OSPF first. Before you configure any layer 3 routing, first the basic thumb rule. What I follow is first I see if I have layer 3 connectivity, I can ping across to my neighbor. That will be 10.50.1.1.1. That's the router interface. Yes, I can ping. I have link up, layer 2 and layer 3 is up, and I can ping across each other, right? So let's configure the OSP connectivity, router OSPF, OSPF 100. Let's call it 100. Then we will advertise network 50.1.1. Let's do this too, and let me bring up my cheat sheet here for wildcard mask OSPF. Alright, this, and let's call the area 85. You can pick up any area, by I choose to go with area 85. And similar fashion, let's advertise our I would call make this 0 and our loop back interfaces, right? Down 100 to 1.1. Okay. So now that we configured OSPF on this here on our external switch, let's minimize this one. Bring the router 4. What are you heading here? Show IP interface brief NSI. Alright, this command will show you whatever the IPs we have assigned, the whatever the interfaces we have assigned IP addresses, as well as if those ports are up. I mean, it makes sense, right? Doesn't make any sense, let me call this way, that you sit there and configure all your routing configuration and you realize the port is not even up, or you don't even have IP address, or you don't even have a connectivity, layer 3 connectivity, and you keep spending hours and hours troubleshooting your routing protocol. So it's a good idea always to go ahead and see if you have layer 3 connectivity across our peers. I'm on the 1.2 and save some time for yourself. Let's configure the OSPF, router OSPF. Alright, this is process ID. You can choose anything, doesn't matter. Now let's call network 50.1.1.1. Let's go back to our cheat sheet. Area 85. The area must be the same. Okay, and I don't have any loopback interfaces or anything, so we'll just do this here. Show IP-OSPF neighbor. Okay, so right, so the OSPF neighbor is up. Then I will do show IP route. Show IP route. There we go. So I'm learning the loopback interface IP address 1.1.1 here, as well as the 100.1.1. 40. This 40.1.0 and this 30 and all are coming from our BGP peers, where we only have layer 3 static connectivity, point to point. We don't have anything, but it's showing here in our IP route. So let me see if I can ping my from router 4 our internal networks 1.1.1, and I should be able to do so. Right, there you go. Okay, so now we have route, and we can reach out those internal networks. Now we completed the task number 1. Router 4 knows how to get to 1.1.1 as well as 100.1.1 also. Now that these routes are till here, now we need to carry forward these routes from router 4 to our New Yorks. How would we do that? We would have a BGP with our dual multiple ISP1 and ISP2, right? So let's go and configure our BGP, and we have the AS number 500 to the ISP1, AS number 600 to ISP2, 200 is the AS number on this router 4, and our New York router has an AS of 100, right? So don't get confused, take your time and see what I'm doing here. Right, so let's hop on to the router 4 and start configuring our BGP. conft router BGP. What is the AS number I have here? It's 200, right? Now you can give some description, but let's do it. Let's do neighbor. Who's our neighbor for 200? Let's configure the router to 30.1.1. 30.1.1. Remote AS. It's 500, right? That's the IP address of our neighbor. Okay. Now to save some time, description ISP1. I will put a description so that during our troubleshooting we know where this link is connecting actually to. And there are many other commands you call in neighbor, but to keep this video short and simple, I will just limit myself to the description and the neighbor command. Right. Then let's also bring our neighborship with the router number 3, from router 4 to router 3. I will just use the easy way, 40.1.1. What is the AS number for this router? Is 600. And make some changes here. 40.1.1. Right? And show run. So let's see my configuration here. Show run sig BGP. This is a command where you can see your BGP configuration. So I have configured a very simple neighbor blah 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 500 and 600. I'm also calling them the description so that during the troubleshooting I would know where this IP address is connecting and to whom this IP address belongs to. Right, now we're done with router 4 configuration pointing to this 2. Then if I do, for example, show IP BGP summary, I won't see anything, right? It never inactive. That means there is something wrong, definitely, right? There is basically all I have is ping connectivity layer 3 connectivity to 30.1.1 that and 40.1.1, and other than layer 3 connectivity and layer 2 I don't have any routing configuration. That's right, makes sense. So let me minimize that and go to the router number 2. So router number 2, let's configure our BGP. So use this command to see my layer 3 interfaces which are up, and I also have the IP address on them. On the router 2, 30.1.1 is my IP address, so let's do conft router BGP, sorry, 500. That's my AS number. Who is my neighbor? First neighbor here is on this side is router 4, 30.1.1.2. Remote AS is the AS number of our router 4, which is 200. And also let's call the description here description router 4. Okay, and so let's see what happens if the BGP has come out. If not, then we will troubleshoot it. All right, now I see the BGP is up, right? It should be in idle, never, and I mean there are multiple stages. I will make another video sometime. What are the different BGP stages before it comes up, right? The BGP neighborship adjacency comes up. So let's not get into that. So IPBGP summary is a command. It shows the hour, minutes, and second. So for the last 24 seconds, it's been up. So I can confirm the same thing on router 4. Router 4 here. Show IPBGP summary. See that? What's wrong? BGP is up. All right. So why this one is showing no, never? Because I configured the BGP towards this direction, but we didn't do anything on router 3. So let's bring over router 3 and get things going. Conft, okay, I don't want to break my own rules. So let's see, starting, okay, I have these two interfaces, 40.1.1, 20.1.1, sorry, 2, the both are up. That means layer 2 and layer 3 are up. Now it makes sense to go and configure. I mean, we are ready for configuration of protocol. That's what I'm doing here. This first, the basic thumb rule is make sure your ports are up, the physical layer 2 is good, and layer 3 is good. You can ping across each other, the port shows up, then you go and do your configuration. So I'm sorry if you guys hear any background noises. You know, in the pandemic, kids are doing school, homeschooling, and the tantrums. We all know that, right? So, right. What was I doing here? Okay, router BGP. What is my AS number? 600, right? Neighbor. What is the neighbor IP address on this one? 40.1.1, 40.1.1.2. Remote AS is 200. And then let's put a description on this one here. Router 4. Show IPBGP. It takes like few seconds for the BGP to come up. If it doesn't come, then we will troubleshoot. See, the BGP is up. You'll see a log here. BGP is up. Okay, now if I do, for example, right, step by step. So if I do show IP route, see, I would only see this 20 dot and 40 dot directly connected interface networks 20, and here this one and 40, right, going to router 4 and router 1, but I'm still not learning the 1.1.1, but we'll get this, we will get that thing also happen. We will move this route from here to router 4, which is still here. Then we will advertise that route from router 4 to this both ISPs. There is a special way of doing that. I will get into that, but let's go and configure our router 1 BGP so that our full BGP is up. Then we will move that route, pass this route 1.1 and 100.1 from Dallas to all the way to New York. Once you confirm that, then we will do the path manipulation, load balancing, right? Okay, now let's go to the router 1 and configure our BGP for router 2 and router 3. Don't worry, it will be quickly done. And so first thing first, Tap into brief. What are my interfaces? 10.1.1, 20.1.1. They both up, and I don't want to spend time pinging, but let's do it. Yes, I can ping my 1.1, my 2.neighbor, as well as 20.1.2 neighbor also. All right. Now let's bring our BGP router. BGP. What is my use number? Is 100. Neighbor 10.1.1.2 remote AS. This is to my neighbor, and remote AS is 500. Okay. Let's also bring the another one. Neighbor 20. Oh shoot! Sorry. Let's say no neighbor. This command. I made a mistake. All right. 20.2 remote AS is 600. The remote AS number here for this number 2 is 600. Then I would, I think I forgot to give the description. 10.2.2 description is the ISP one. Oh, I gave exclamation instead of one, but let it be. And 2.2, let's put the description. ISP2. There you go. Instead of 2, so let's undo this both. Yeah. Oops. No neighbor. Then we go and fix this command. Give proper description to it. There you go. ISP2. This command basically would undo whatever the line you have done, and I will call this neighbor so ISP2. And so the best way of saying, you can go back and check what you have done. Configuration is this command show run sec. You see that description 600 ISP2 remote is 500 and ISP1. Basically, this is our BGP. So if I do show IP BGP summary, see, okay, why this is not coming up? Let's give a few. Let's give some time for the BGP to come up. If not, then we'll troubleshoot. So if the BGP don't comes up, right, we know we already have connectivity to these IPs, right? Second thing we do, if we have configured the BGP on our neighbors router 2 and router 3, which I don't think so. Show run sec BGP. This will show you my BGP configuration. So I never configured the BGP on router 2. So let's do that. Conft. Let's use the easiest way. Copy this. Neighbor. What is that? 10.1.1.1 remote AS 100. Description. Let's call router 1. Oops. Okay. And let's go to the router number 3. I don't think I have configured the neighborship towards New York. How to check that? Show run sec BGP. This will show our BGP configuration, which only shows I have configured towards the Dallas router 4. I don't have anything on router 1. This is the main purpose of using description to see what configuration I have and to which router it's pointing to. So let's do this. Conft router BGP 600 neighbor 20.120. Sorry. Fat fingers 20.1.1 remote AS. Alright, same thing, and just delete this and put the description, please. Description router 1. So by doing all this BGP configuration, I think our BGP towards router 2 and router 3 should also be up. and I don't see a reason why it won't. So now we have the BGP towards 10.1.1.2 and 20.1.1.2 to ISP1 and ISP2. I mean, in the latest code, it also shows the description here, ISP1, ISP2. Because I'm putting this description, I was expecting it will show the description where this BGP peers belongs to the neighbor. But in the latest code, I have seen it. This code is not showing that. As you all know, this is Genesis, right? Sorry, the GNS3. My bad. Shows BGP. So the BGP is up. In fact, I was working with one of our client, Genesis, so I got the Genesis stuck in my head. Right. So the BGP is up. Okay. Now show on the sitting on the router 1, right? If I do show IP route, I still won't see anything from our Dallas network, even though my BGP is up towards router 1, router 2, and router 3, and BGP is up on router 2 and 3 towards router 4, but we're not learning anything. The reason because we are advertising this network to this guy on OSPF. But this guy is not advertising its OSPF routes to the ISP. And the ISP is not advertising to this. The reason the ISP is not advertising this route because the ISP itself don't have this route. And how would you know that? Log into router 2, show IP route. See, the ISP itself doesn't have that route. So how do we resolve that? So it's time for us to hop onto the router 4 and push this route, this guy, right? This guy is this guy from here to this, and this in return the router 2 and 3 would advertise to the router 1. And how would we do that? So log into the router 4. We go into the BGP. This is my BGP configuration, which shows what configuration I have on my BGP, right? And I don't see a command here which will advertise my internal OSPF routes to the BGP. So the command will be called ft. I will go on router BGP. Redistribute. Oh, sorry. There you go. Redistribute OSPF 100. So what he's basically saying is, on the router 4, if I do this command, right, show run set OSPF. So on the router 4, I have OSPF as well as I have a BGP. OSPF is the internal routing protocol pointing towards my internal switch, the core switch, and I have a BGP which is connecting toward the external network, router 2 and router 3. So basically doing this redistribute OSPF, what I'm telling the router 4 is, whatever routes you have learned from OSPF, the internal route, go and merge them into BGP. That's what it is saying, right? Now if you see here, let me go into the router 2 and see if I have those routes. Right, now you see that I have 100.1.1 as well as 1.1.1 networks in my routing table on router 2. Let's see if it is there on the router 3. There you go. 1.1.1 and 100.1.1. So now this route, right, has taken this path. It's going here and also this direction. Now we will see how this route, now this, to get to this Dallas, we have two routes. Either the traffic could go to the ISP1 or it could take ISP2. We don't know that. So how would I know? I would log into router 1, show IP route. Let's see if I have my Dallas route. See, I have a Dallas route 1.1.1 as well as 100.1.1. So I'm going to ping to see if I have reachability to Dallas. And I should. Let's see if I can reach to the 1.1.1. I see the reason why we are not able to reach. Let me get into more specific on that. But let's see how we learning 1.1 and 100.1. I mean, when I say how we learning, of course, through ISP. But if I say show IP route 100.1.1, it's preferring 10.1.2. So this router 1 is learning the routes from both router 1 and router 2 and router 3, but it's preferring router 2 to reach to the Dallas network 1.1.1, 100.1.1. How would I know that? This star means the best route, the preferred route is 10.1.2. That means if I have to reach to the Dallas network, I will hop on to the next hop 10.1.2, then it will go to router 4. And so how do we go? I mean, you can do a trace route 2.2. That was quick. 2.8, 1.1.2, then it has taken to router 4 and to the external switch 1. If I do show IP BGP, the same command to check my routing table. Show IP BGP. There you go. So to get to the 100.1.1 network or 1.1.1 network, either I can select this 2.1.1.2, this route, or I can select this one, 1.1.2. But if you see here, this star and exclamation points to this 1.1.2. That means this network is preferred, right? And if I have to select to go to the another network 100.1.1, again I have two options. I'm running this route from 20.1.1.2, this one, as well as 10.1.1.2, right? But when you see this, right, star and greater than symbol, that means valid and best. So it's preferring 100.1.1.2 to be the best route. Why is it doing that? There could be so many things. The BGP, but we would get into the specific later on because of I want to keep this video short and simple. The configuration point, later on I will make videos, the path selection, what scenarios and all. So it's taking this route. So I will make video number 2 where as you all have just seen, right, the router 1 is preferring router 2, the ISP1, basically to go to the Dallas. So like your management say, no, ISP1 doesn't have a slow sluggish performance. We don't want that. We want all the routes to prefer to router 3 going to the Dallas. Router 2 would only come into action when there is a link failure on router 3, right? So primary is router 2 now as we speak, and router 3 is the secondary based on this output, right? 20 best and valid, this one and this one, right? It's stream for both networks taken 1.1.2. So in the next video I will make a BGP configuration where there are multiple ways of doing that, but I would use the AS path preprints and the route maps and the prefix list to influence the BGP path selection, right? Telling router 1, hey, to reach to the Dallas 2, instead of going 1.1.2, you need to go to 20.1.1.2, then go to router 4 and all the way here. And another video also I'm going to show you why we still cannot ping from router 1 to the router 3 networks. If I do this ping 1.1.1, see, it's not pinging, even though I have a route. And the reason being is router 1 knows how to get to this network, right? But the return packets on the external switch 2 doesn't know how to get to the router 1. I can give you a quick proof on that. All right, if I say on this switch 1, show IP route, we don't have any 10. Network route here on external switch, and I would bet router 4 also doesn't know the let's see, how to get to the New York. New York know how to get to the router 4 and Dallas because of the BGP we're advertising through OSPF. But the return packet, the packet that means whatever we're saying, for example, right? Let's say like this guy knows how to get to router 2, to router 4, and here to reach to the Dallas network. But the Dallas network, the people sitting here, they don't have a route to go to the New York, right? So to communicate, to have a successful communication, they both should learn each other routes, right? If I go to the router 4, say show IP route, see, I don't have the 10 dot network, right? And so any packet leaving from this one, right? Any user, any packets, right? The frames leaving, going to, so like this, imagine this is a network packet, right? Let's do this way. We'll just draw a small. So this is a layer 2, layer 3, your packet, right? Your frame, right? Knows how to get to the Dallas. It goes, as this is a primary path, it goes to router 2 to the router 4 and goes here, right? But the return traffic, right? Whatever the after the TCP three-way handshake and all, the return traffic during the handshake itself doesn't know how to get to the 10. This router 1, the router 1 knows how to get to the router 4 and external switch, but external switch doesn't know its address, right? Because we don't have that 100 dot network entry, we're routing table and router 4. If router 4 doesn't have it, obviously it won't share anything to external switch. What you don't have, you can't share with people, right? Similar way. See, the router 4 doesn't have 10 dot network, right? So in next video, I will show you that. We'll troubleshoot that once we have 3 reachability in the part 2. Like we can ping from router 1 to router external switch 1 and router external switch 1 to the router 1 network inside. We'll create some loopback interface here also. Once we've done that, then we will do the path manipulation of changing the routes. So that was a quick video. I hope you guys enjoyed it. If I'm really fast, leave a comment, and please don't forget to subscribe and hit the bell icon. And I want to keep this interesting, short and simple, but again, it's a networking, right? Everyone has a different approach of looking at things and configuration. There are multiple ways of doing it, and I'm sharing what is best for me. Thank you so much, and hope you enjoy this, and take care. Thank you.